Assalamu alaikum students. So in this lecture we are going to practice few questions on rational and irrational numbers. As we have already done in the previous lecture, let me give you a quick recap that rational numbers are numbers that can be expressed as a ratio of two integers such as p over q. For instance, if I have two numbers like p and q, given that q is not equals to 0, then the quotient of these two numbers would be a rational number. For example, 10 over 2 equals to 5. So here 5 is a rational number and it is denoted by q. Similarly, if we take any number whose result is a recurring decimal number, for instance, if we take 4, let me write here. If we take 4 over 3, so when we divide these two numbers we'll get 1.333, and since this is a recurring number we can write them as 1.3 bar or 1.3 dot. So this is again a rational number. And when we come to irrational numbers are those numbers that cannot be written as a fraction of two integers. They are non-repeating, non-terminating decimal numbers. For instance, let me clear the screen first. Let's take an example of 22 by 7. This is a fraction, and when we divide them both using a calculator, we'll get some digits like 3.1428557. We have more digits after 3 also. So this is, we can say that these are non-repeating, non-terminating numbers after decimal. And when I convert this decimal number back to fraction form, I'll be unable to end up. I'll be having more zeros and I cannot write it in the form of a fraction again. So this is an example of an irrational number, and irrational numbers are denoted by q prime. I hope this is understood. Let's move to the next slide. So in the first question it says, let's see the question first. It says, determine which numbers in the set are natural numbers, integers, rational numbers, irrational numbers. So here you can see that there are 6 questions, and these questions are given in the form of a set. Let's take one set and find out about each number, starting from the very first number, which is -9. But before we start categorizing them as mentioned in the question, it would be better if we draw a column so that it's well understood. Let us draw 4 columns first. Let's name them. First, they say natural numbers, so natural numbers are denoted by n. Then integers are denoted by z. Rational numbers are denoted by q, and irrational numbers are denoted by q prime. So initially over here the first number is -9, and since you can see that the number itself has a negative sign, so all the numbers that have positive and negative signs lie into the category of integers. So let's mark this first number as integer. I'm writing this in the column of z. Moving to the next number, this is 7 over 2. Again this number is having a negative sign, so students may mistake over here. They consider seeing the sign and put this number wrongly into the category of integers. So here the point of focus is that integers are only non-decimal numbers. They are the whole numbers. Whole numbers, I meant to say that they have 0 after the decimal sign. So negative 7 upon 2, just don't see the sign, see the number also. So if you want to be sure, divide it using calculator and see what number are you getting. So this is not a natural number, this is not an integer number. This is negative 7 over 2 is 3 by 5 with the negative sign. So it would come under the category of rational number. So I'm putting it in third column. Now moving to the next number, which is 5. So you can see that 5 is a whole number and this is positive, but we are not given a whole number as category, so we would put it under the column of natural numbers. There is a slight difference between natural and whole numbers. Whole numbers begin from 0, they are all the positive numbers and they lie on the positive side of a number line, whereas natural numbers begin from 1, again they are positive numbers and lie on the positive side of a number line. So 5 is a natural number, so I'm putting it in the first column. Let's move to the next number, 2 upon 3. Again, we'll check this number using a calculator. So calculator shows that 2 upon 3 is equals to 0.6666, as we have discussed earlier, that this is, since all the digits are repeating, it's repeating themselves after decimal, so we can end up writing 0.6 bar, and this is again a rational number by definition. Moving to the next number, which is square root of 2. When you use calculator and check the value of root 2, you'll have several digits after decimal which are non-repeating. Let me write them for you. 1.414, 2135, 62. There are many more numbers and you can see that they all are unique. The set itself is non-repeated. Numbers are unique and there are many numbers after decimal, and we cannot write all of them back in the form of a fraction. So this is again an irrational number. So I'll simply write root 2 under irrational number. Now the last one, which is 0.1, and here decimal, after decimal you have only one digit. This is by definition a rational number because this is a terminating number. We have only one digit after the decimal number. So this is a rational number. I hope this is understood and you would be able to solve the rest of the questions from 2 to 6. Let's move to the another slide. In the next slide, there are many more questions given. Let's see from 13 to 18 first. The question says, plot the two real numbers on the real number line and place the appropriate inequality. For this, we need to see question number 13 first. Let's start with question number 13. In question number 13, we are given two numbers The first is 3 by 2 and the second one is 7, and we want to find which number is greater. For greater, we'll use the inequality, and let's convert the fraction number into decimal first. So 3 upon 2 is equal to 1.5, and at the right hand side we again have 0. So if I explain using a number line, we'll see that both of these numbers would lie on the positive side of the number line, and as we go away from 0, we are heading towards the greater number. So 7 is away from 0 as compared to 1.5, which is nearer. 1.5 lies between 1 and 2, which is near the 0, and 7 is 2 away from 0 on the positive axis. So we can say that the number which is away from 0 on the positive axis has greater value as compared to the number which is near 0. So 7 is greater, that's why we'll put the inequality with the mouth open towards 7 and the back of the sign towards the smaller number. Let's solve one more question for practices. Now let's see question number 14, which is different in the sense that both are negative number. So again we need to draw a number line. Now since these both numbers are negative, so we'll mark them on the negative side on the left side of the 0, and we'll see that which is near the 0 and which number is away from it. So guys, you can see that as we move towards left, we are heading towards a smaller number, because on the negative number line the number which is away from 0 is smaller and the number which is near 0 is greater. So here you can see that -4 is having a small distance from 0, whereas if I extend this number line and I draw more numbers, I'll find that -8 is away, too far from 0. That means -8 is smaller than -4, and similarly we can say that -4 is greater than -8. So for greater, we remember that we put the inequality sign with mouth open towards the greater number and back towards the smaller number. I hope this is clear. Let's solve one more for practices. Question number 18. Now in question number 18, both the values are in fraction. So there are two ways to solve them. First is either convert them into decimal numbers so that you can find out which number is greater and which one is smaller. And the other way is to check the denominator. If the denominators are same, like in this case both the denominators are same, so we only need to check the numerators. And we'll apply the same rule as I have explained in the previous question. -8 and -3, the number which lies near the 0 on the negative side or on the left side is -3, whereas -8 is away from 0 on the negative axis. So -3 is greater in value than -8. So we'll put the inequality sign with mouth open towards the greater number, which is -3, and back towards the smaller number, which is -8. I hope now you would be able to solve the rest of the questions. From question number 19 to question number 22, they have given again a sequence of numbers, and it is required to use calculator to first convert them into decimal numbers and then to check if the number is smaller or greater. Since the requirement is already given that you have to move from least to greatest, that means a smaller number would come first and the greatest number would come at the last. So step by step we'll convert all the numbers into decimal numbers, and then we'll number them from least to greatest. I hope you would be able to solve it using the same example as we have done in the previous case. Let's move to the next question. Oh guys, great. This was the last slide. I hope you would be able to solve all of the given questions. Thank you.